Hey everyone, today we are going to be talking about content delivery networks. And specifically, let's take this example. Let's say that we have users from three different countries, India, USA, and Netherlands. And we also have a server which has HTML pages that is to be served for all of these users. When you type in facebook.com, you get an HTML page through which you interact with the server. Also, you have databases. So these databases are going to be storing information like user information, session information, anything which is specific to your application and dynamic is going to be stored here in this database. While you have a lot of static information like HTML pages and so on. The problem is that whenever a person needs to connect to our server, it goes and hits our server and asks for an HTML page. So this is fine. I mean, if you have a few users that you are catering to, but not only could you make this much more fast, you could also make it much more efficient by using ideas that we commonly use in computer science. Okay, so firstly, you're seeing that there's a lot of distance that is being traveled every time a user is actually calling for HTML page. So can we use the first principle of caching things? That's idea number one. We want to cache static pages onto the server so that we don't need to make this call every time. Maybe this is in a distributed file system. Okay. The second thing is that you may have different types of HTML pages that you want to send to different types of devices. So this is a desktop, this is a mobile. The HTML page for a mobile is going to be a little more, let's say, smaller and longer. It's also going to be maybe more responsive. Depending on the device, you are changing the requirements of the HTML page. So there is a customized data that you want to send, and this is according to device or location. Okay. So how many devices do you have per application? Maybe you note down 50 devices, or maybe you note down just 5 devices, type of mobile, tablet, desktop, laptop, etc. And you get 5 combinations that way. And for each combination, you're looking at the location. So there's, let's say, 200 countries. So you have at most, I mean, if you're serving all 200 countries with unique web pages, then you have 1,000 unique data points that you'll be serving. So, which is a manageable number. You can actually keep this in the cache that we are going to be creating. The other thing, point number three, is that you want this to be fast. You want your web pages to be served to the users quickly, because if they have decided on buying something on Amazon, let's say, if it takes 2 seconds to load, their interest in the product will reduce dramatically. The same thing happens with the Google search. When you open a new tab and you type something in, you want the search to complete quickly. Otherwise, it's irritating. It causes some cognitive load for you to wait. So you want this to be really, really fast. Okay. So taking this stuff up, what principles can we use? Well, firstly, we don't need to keep the cache on the server. We could keep a specialized global cache, which is going to be taking all these requests for HTML pages and serving them. So before the server, you have another entity which is a cache, right? And this is just taking static information. Let's say that we don't want to deal with the problem of dynamic data and us invalidating the cache and stuff like that. We just want to keep static information. Sounds simple enough. Write once, delete never, update never, cache. So all the requests for getting an HTML page or for getting static content are now being redirected to this cache, and all the other more interesting requests are being sent directly to the server, which then consults the database to get relevant information and send it back. Okay. What is one possible problem with this cache? Whenever you see this nice kind of a bottleneck in a system, the first thing that should probably be striking you is that this is a single point of failure. If this crashes, everything crashes, the whole system collapses. So what can we do to mitigate this problem? Well, we can make it a distributed cache. All you need to do is just draw a couple of extra boxes on the background and it becomes a distributed cache, at least on the whiteboard. But okay, fine, you have a distributed cache. Let us assume that distributed consensus is no longer a problem. You have Paxos, you have Raft to take care of that. Even then, we have some issues. If you take the users from India, they are only concerned about 5 pages. right? 5 Indian pages, and we are storing a lot of irrelevant information in this cache for no reason actually. For when it comes to Indian users, so if we are going to split this cache, we can horizontally shard. That would be sharding based on country, based on location rather. So you might have states within the US, maybe California and maybe Texas need to be shown different pages. Okay, but you have states within the US which will be served different pages based on the location of the user. Okay, so we are understanding that this cache is a distributed system, it has distributed consensus, but more importantly, you're taking requests from different users and treating them differently. So the green user is going to the green part of the cache, one of those boxes, and the blue one is going to the blue part of the cache. So one instance. This makes sense. However, there is still a problem. The problem is that you have this distributed global cache in your cloud, in your system, which is probably hosted in a single country like USA. So the Indian users are being sent to a group of nodes, which are caches, but it's not still serving the purpose right, because the Indians are still sending a message which is traveling all the way to the US and then coming back to them just to get a silly HTML page, right? So you don't want to do that. What you want to do is you want to either construct a data center in India, which is how things seem to be going, or you can create a cache here in India through which Indian users can access the HTML page. With that change, we are able to serve Indian users using an Indian cache which is placed very close to them geographically, which is basically India, let's say, or somewhere in Asia. So the request and response times are quick, the latency is less, which means that this system is now fast. Okay, that is one requirement that is taken care of. Similarly for the US users and similarly for the Netherlands users. The second thing is that this customized data is now being stored in the relevant places according to the location of that data. So Indians, Chinese, people in Asia can be served by a single cache which is close to them, while the people in USA, maybe they speak a different language, maybe they want to see different things on the Amazon web page, they can see it here in the US cache. And I mean similarly everywhere else. So this is taken care of. And the third thing is caching. So why am I talking about a cache? Well, in any distributed system, there needs to be a single source of truth, which is here and here. So your server always has access to that source of truth. What is being stored here in these boxes is not, let's say, the source of truth. Because if someone needs to know what exactly Interview Ready is talking about, they don't go to the CDN and say that what they're talking about. They actually ask the server, which makes the data in these boxes copies of the original data of that source of truth. So that would be called replication or a copy. But because these blocks of data can be removed from this cache, okay, I said insert once, remove never. Well, that's not practical, because if you are going to change the web page, the HTML page also, for a particular country, you have to remove that page, or at least you have to version it and then put it out of service. You have to bring in a new page. So these are effectively caches. Now, as a small company like Interview Ready, how do you afford to build caches in different countries? How do you make sure that the regulations are being followed? How do you make sure that these are invalidated in the right time? People have already done it. If you have a look at certain specialized solutions like Akamai, what they provide is a content delivery network. A content delivery network takes care of all of this stuff, right? Hosting boxes close to the users is something that they specialize in. Making sure that they follow that country's regulation is something that they specialize in. And also, invalidation or posting content in these boxes is easy because they provide a nice little UI which does this for you. If you are an engineer here, all you need to do is use the UI that they are providing to fill up these boxes in different places, and then you don't need to worry about how you're going to handle these caches. Like, most of these caches have a time to live also. Sometimes you want the data to only exist for 60 seconds or for 30 minutes. So whatever be that, you get a nice UI to set this up, right? Otherwise, you would need to actually create a cache and then have some sort of a cron, or you would have some sort of check on every GET request that, hey, is this invalidated or not? And if it is, then go and fetch data from here. All that stuff is taken care of by the solution provider, which is a content delivery network. The most popular content delivery network, I think, is S3. We use this at Interview Ready to host our files. So in case you are seeing some sort of system design or any kind of architecture diagram, it's on S3. And the reason we use it is because A, it's super cheap, B, it's very reliable, and C, it's easy to use. So all of the three things for a business are, tick marked when you use S3. But if you have any other solutions that you know about, do let me know in the comments. Of course, if you have any doubts or suggestions on this video, you can let me know in the comments. If you want more detailed videos on system design, you can head to interviewready.io. And if you like the video, then make sure to hit the like button. See you next time. Bye-bye.